In this video, we want to integrate, evaluate this interval 3 ways, and then confirm those results. So if you want to pause the video and try this out, go ahead, then I'll be back. Now the first two methods are actually going to be the U-substitution. So I'm going to let U equal to the sine of x. Then du equals to derivative of sine is cosine. Get cosine of x dx. Now we convert this integral to the variable u, from x to u. So obviously sine of x can be replaced by u, and cosine x dx right here can be replaced by du. Very basic integration here with respect to u. Add 1 to the exponent, that'll give us a 2. Divide by that value, we get 2 plus constant of integration, c. And go back to the original variable. U is sine x. I get sine squared of x over 2 plus c. That's your first answer. And let's confirm this quickly here. For this particular one, take the derivative here with respect to x. We go using the quotient rule. The 2 comes out in front. Subtract 1 from the exponent. We get just plain sine to the first, or just sine of x. Then times the derivative of sine by using the quotient rule. Derivative of sine is cosine of x. Obviously the derivative of a constant is 0. This was over 2. So these cancel out, and we get the integrand, sine x cosine x. So that checks out. Now the other way we'll do it, let's let u equal to cosine of x. And this time the derivative of cosine is minus sine x dx. So let's start it here in this case. This will be then equal to, using this substitution here. In this case, u is equal to cosine, so this cosine here can be replaced by u. And then put these together over here. Sine x dx, multiplying by a negative here, this will be negative du. And this will cancel out, so I get sine x dx is equal to minus du. So replacing the sine and the dx by minus du, I put the minus sign in front here. This will be du. And then we integrate with respect to u. Minus comes along for the ride. This will be u squared. Adding 1 there and then dividing. You get minus u squared over 2 plus a constant. Go back to the original variable now. So it'd be minus, then u is cosine of x, quantity squared, over 2, plus your constant of integration. And then we say, well, these have to be the same. Different u substitution, but those have to be the same. So we can confirm this. Actually, in this case, we can do it 2 ways. We can either use an identity here. Let's do this one a little bit different. We know that cosine squared plus sine squared on an angle is equal to 1. So that means I can replace minus cosine squared. Let me write it over here. You know, cosine squared of any angle, in this case we're dealing with x, plus sine squared of that same angle is equal to 1. So let's take the cosine squared to the other side then. We can rewrite this then as sine squared x is equal to 1 minus, and let me make it this way instead, taking the 1 over to this side, sine squared of x minus 1 equals to minus cosine squared x. So this right here, the minus cosine squared x, can be replaced by sine squared x minus 1 over 2. But if we break this up here, this can be written as sine squared x over 2 minus 1/2. Sine squared x over 2 minus 1/2. So if I do it that way, put the minus 1/2 over here. And of course, this is just a constant. So that can be absorbed with the c. And that's one way to verify it. You could also do it like we did the first one. Take the derivative. So the derivative of c right here, that's 0. So in other words, remember we have to get this right here. Derivative of c is 0. And the derivative minus cosine squared of x, using the chain rule, will give us the minus 2 here. Subtract 1 from the exponent. Will give us the cosine. Of x. And the derivative of cosine is minus sine. And that's over 2. So these cancel out. You get a negative here and a negative here. That becomes positive. And we get sine x cosine x. And the final one is not related to the U-substitution here, but we can do it this way. This is going to equal to, I'm going to write it this way, 2 sine x cosine x dx. And that's over 2. And all I did there is I multiplied the numerator and the denominator by 2. See, these cancel out. So I still have the same thing I started off with, sine x cosine x. But there's an identity for 2 sine x cosine x. And that identity is sine of 2x. Sine of 2x is equal to 2 sine x cosine x. Double angle identity. And that's over 2. Now we can take the antiderivative of this. The integral of sine 2x, the constant doesn't matter there, is minus cosine of 2x. And then because it's a 2x here, we have a factor of 2 in the bottom. And you have 2 there already, so it's 2 times 2. This will give us a 4. And this is plus your constant of integration. And this one looks a little bit different because we use this double angle identity. But here's an identity for the cosine of 2x. There's actually 2 others, but this is the one I'm going to use here. So this tells me that cosine of 2x is the same thing as this. Now this is the answer right here. That's the integral. But so that you can see that it is the same answer, I'm going to do this over here. So let's just say this is equal to, so this is a minus then, and then I'm going to put the 1/4 out in front here. So this is the answer using the third approach. I'm just rewriting it here. So I'm using this identity that cosine of 2x is the same thing as 1 minus 2 sine squared of just the single angle x. And then if I distribute here, minus 1/4 times 1 is minus 1/4. And I still have my constant of integration here. I'm just rewriting the answer. This right here. Then minus 1/4 times a minus 2 is a plus 1/2 sine squared x plus, again, my constant of integration. Now for the first answer, all I got was this. For the first answer, using the first U-substitution, we got 1/2 sine squared over x, or you can rewrite that as sine squared x over 2. And then you might say, well, look, we have another extra number here, minus 1/4. But remember, minus 1/4 is just a constant. So I could rewrite this as sine squared x over 2 plus a constant. I'm going to call it k. In other words, I'm taking this constant and putting it with this. So the point is, all the answers are the same. And just to confirm or show you again, these are the answers we got. Sine squared x over 2 for the first one, plus constant. Second answer, again using the U-substitution, minus cosine squared of x over 2 plus a constant. And for the third one, see how similar these look. This one and this one. Sine squared x over 2, sine squared x over 2. This has a constant, this has a constant. If we wanted to, we could put that, absorb that constant of minus 1/4 with the c. So, point is, they're all the same. Thanks for watching, we'll see you next time.